Welcome back, everyone. This week, we're going to discuss some new topics about the periodic table. But first, we need to talk a little bit about elements and how they behave. So in previous chapters, we've talked about the boiling point and freezing point of water and other elements, molecules. We've discussed physical changes, changes that occur when ice melts to water and water boils, phase changes, things where we can heat them up or cool things down and they'll go from being a solid to a liquid or a liquid to a gas. A physical change doesn't change any of the molecules of the substance. It only changes its phase. Right? So if you freeze ice and then melt it, you can go back and forth from water to ice as many times as you want, so long as you keep freezing it and allowing it to melt. And so physical changes are generally reversible changes. And you just reverse them by doing essentially the opposite of what you did. Of course, there are things that can be physically changed that are harder to reverse, but they're generally reversible. In this chapter, we're going to discuss chemical changes. And chemical changes occur after two different substances react with one another. Here, the chemicals themselves, the molecules actually change. They become something different. They become something new. These chemical changes are not always reversible. Not only are they not always reversible, generally you have to do something completely different to reverse them. As opposed to freezing and melting water is a pretty simple process that you could reverse over and over again. When you burn gasoline in your car, it's pretty hard to put the gasoline back into the car. There's another example of a chemical change that I like to discuss. Sodium, which is a metal that you see here in picture A. It's a soft, brittle metal that will react violently with water. You can look this up on YouTube. I don't suggest you ever try this, but there are videos of people throwing chunks of sodium into water, and it has a pretty violent reaction. People also put it in their bathtubs, but don't try to do this. It's dangerous. The violently part is true. Chlorine gas, chlorine alone by itself is generally a gas. Here I just have it as a picture in a chlorine tablet for a pool because you can't show a picture of a gas. But it was mustard gas. It was used for warfare in World War I. They outlawed it afterwards. So it hasn't been used since. Alone, chlorine gas will kill you if you breathe it in. But take these two things, put them together in a reaction, and you get sodium chloride, which is something that you eat every single day. It is completely different from the other two. It is completely different from sodium and chlorine, but is the combination of those two atoms, those two elements. It is chemically changed from the two things that it starts out as to something different. And that's part of what we're going to focus on this week and next week.